All right, let's solve 13 derivatives. So one of the only few things you need to know in solving these derivatives before it gets to more special derivatives is the following: nx n minus 1. What this means is, let's say we have some exponent. You're just going to multiply this value with whatever value is in front of your variable. In this case, it's going to be a 1, and we're going to subtract 1. So 2 multiply 1 gives me 2x, and then 2 minus 1 is 1. So I can rewrite this as x to the 2. So all you need to know. And obviously some exponential rules. Anyway, so let's derive this function. If I derive x squared, we just did it over here, it becomes 2x. Okay, what about the next one? Well, the next one, I'm going to follow the exact same principle or technique. I'm going to take this 3, multiply it forward. That gives me 12x. And I'm going to subtract 1 from 3, which gives me 2. So it becomes 12x squared. Now for the next one, we can do a little bit of factorization. So I'm going to first factorize. Okay, so d over dx. I can break this up. I can say, well, I'll do it over here. 4x squared over 2x times 2x, or x squared. I can cancel out one of these x squares, since in multiplication we can always simplify. We cannot simplify with addition and fraction, but we can simplify with multiplication. So I'm left with 4 over x squared. Now I'm going to continue my calculation over here. So now we can derive respect to x, 4x squared. So first things first, I'm going to bring, let me actually continue over here. I'm going to bring my x squared to the top of my fraction. Now how can I do that? Well, you need to be familiar with the exponential rule, where we can take, let's say we have 1 over x. I can rewrite this as x minus 1. Okay, so in this case, it's going to be 4 multiply x to the second power. Now, we can derive this function. We take our negative 2, we multiply it forward. That gives me negative 8. And negative 2 minus 1 gives me x to the power of negative 3. Now I can rewrite this. I want to now put it in my original form, or the given form. Okay, this is the given form, which then means I'm going to say negative 8 over x to the 3. Now let's look at this. So 1 over x, I can rewrite this as x to the power of negative 1. But I can also rewrite this into 1 over x. Okay. What about the next one? So this would be my final answer. So what about the next one? Now we have roots. Okay. For roots, we need to be familiar with another exponential rule. And this exponential rule states that, let's say I have the square root of x, whatever values over here and whatever values over there, I can rewrite this as, so it's the exponent value and the root value, right? I can rewrite this as a over b. A over b. So let's rewrite this, or this differential, as x to the power of 1/2. I can solve. So x to the power of 1/2. I mean, you don't necessarily have to write the d over dx. I'm just doing it for the video purpose. So in this case, we can have x over 1/2. So let's do it. Let's multiply this forward. So 1/2 multiply 1 gives me 1 over 2 x. And now we're going to say, well, 1/2 minus 1. Okay, if I want to rewrite this, I can write this as 1/2. You need to know how to subtract two fractions. In that case, we need to have the same denominator, so it becomes minus 2 over 2. So that gives me minus 1 over 2. Now, how do I get this positive? Well, we simply take it below the line. So it's going to be 1 over x to the power of 1/2, and then I want to rewrite it in my original form. So if I do that, I can say, well, It's going to be 1 over 2 square root x. Okay, what about the next one? Number 5. Well, number 5, I'm going to rewrite as 4 times x to the power of 4. And in this case, we can now say, well, I want to differentiate it in this form. So usually this step would be skipped in most situations. But again, I'm just doing this for the video. Now I can take this 4, negative 4, and multiply it forward. That gives me 16x to the negative 5th. And I can rewrite this as 16 over x to the 5. Now I want to show you guys a little tip here. Let's say we're given this form. Right, so excuse me. You can make some observation over here. So we know the answer should be 16 over x to the 5, right? After we differentiate this, we can sort of think about it as a function or this x value. So what happened is I simply added 1 and I multiplied the top with the reciprocal, meaning the opposite, or not the reciprocal, the reciprocal symbol or reciprocal order of operation, which would be a negative 4. So we can make this conclusion, well, if I have 4 over x to the power of, let's say, 2, my final answer would be, I know I have to multiply 1 and I can multiply this with the negative 2. I need to add 1 and multiply with the negative 2. So without even rewriting, I can simply say, well, this is going to be negative 8 over x to the 3. So you can sort of make this conclusion. Again, it's very important, as I mentioned in every single video, that you need to look at your mark scheme. A mark scheme is the way an educator indicates or tells you an equation counts 3 marks or a problem, which means you cannot just write the answer. You will get 1 mark, okay? So in this case, let's say this one's 3 marks. You'll get a mark for this, you'll get a mark for this, and you'll get a mark for this. Okay, very important to keep a mark scheme into mind. So let's differentiate the following. So minus 1 multiply forward, minus 1 multiply forward, minus 1 multiply forward. Now this is a special case. So you need to be familiar with that the derivative of any constant is 0, and I'm going to prove that in a little bit. That's my question 13, if I'm not mistaken. So 2 multiplied 3 is 6, minus 1. That gives me 312x squared, and there's my final answer. Okay, let's go to the next one. Number 7. So the derivative of any variable is simply 1. Okay, in theory, how does it look? Well, x, this is currently x to the power of 1. So we multiply this 1 forward, that becomes 1x, we subtract 1, which then gives me x to the power of 0. And following our exponential rules, we know that anything to the power of 0 is 1. So whenever you see any derivative of a single variable besides c, so it's generally x, y, and z, then we can state that as 1. Okay, for the next one, we want to factor. We want to factor first. How do we factor this? Well, we can say, we can factor out with an x. Okay, both of these terms consist out of an x. So I can say x, 2x plus 1 over x. I can cancel out these two. So this thing gives me, I need to differentiate the 2x plus 1. So the derivative of any constant is 0. Just keep that in mind for now. The derivative of any, let's put it this way, the derivative of any number is equal to 0. So then we said the derivative of a single variable with the first degree, okay, these exponents are called degrees when we get to functions. So my final answer will simply be 2. Okay, what about number 9? On number 9, I can first factor. I can factor number 9 by saying, well, x minus 3, x plus 3 over x minus 3. This is the difference of perfect squares. The difference of perfect squares tells me that if I have a square value minus a square value, I can rewrite this as right. So in this case, we can cancel out. So we're only going to differentiate for x plus 3. And in that case, if I differentiate for x plus 3, I simply get 1. Okay. What about the next one? Number 10. Well, number 10 is 7 square root x. Well, in this case, I can rewrite it as 7 times x to the power of 1/2. So we know now that we're going to subtract 1, and we're going to multiply this 1/2 forward. So if we multiply it forward, it becomes 1 multiply 7 over 2. Okay, very important. 1 multiply 7 over 2. So it's going to give me 7 over 2, and then x to the power of -1/2. We can switch this one to the bottom to make a positive, which is then going to give me 7 over 2 x to the power of 1/2, which I can then rewrite as 7 over x square root, or 2 square root x. Okay, number 11 is a little bit more tricky. So for number 11, we can say, well, we can rewrite this as 2 times x 4 over 7. In this case, now I need to multiply my 4 over 7 forward. This gives me 8 over 7 x. I can subtract 7 over 7, which gives me 3 over 7. So it's going to be -3 over 7. Now, what we can then do is we can say, well, 8 divided by 7, we take this downwards, where we get this x to the power of 3 over 7. And then I can rewrite this as 8 over 7, 7th root of x cubed. And we can leave it in that form, or as my final answer. Okay, I'm running out of space here. Okay, so what about 1 over x? I can rewrite this as, by now you hopefully see the pattern, I can rewrite this as x to the power of -1/2. So what this means is I'm going to multiply my -1/2 forward. In this case, it's going to be -1 over 2 x, -1 over 2x, and we have 1/2 minus 2 over 2. So it's going to be -3 over 2. I can make this positive to say -1 over 2 x 3 over 2. And now I can simplify this. So it's going to be -1 over x. Okay, so it will be 2x cubed. And now let me rewrite this over here, because I'm sort of running out of space now. So let me show you what we can do with this one. This simply means that 2, the square root of x times x times x. Since I have some square rootable value there, I can move one of these x's forward. So now all of a sudden it becomes, sorry about what I did a bit earlier, I should not have done that, where you take the x and then you can just make a 1 over 2. I failed to mention the final x. But in this case, now I can just take one x forward, so this becomes x and then the square root x. So I can then simplify this to say -1 over 2x square root x. So there's my final answer.